Understanding Matrix Operations, a simplified guide. Hello, and welcome to our learning journey. Today, we're going to unravel the mystery of matrix operations. If you're passionate about mathematics or curious about how numbers work in groups, you're in the right place. Matrix operations are not just numbers on a page. They're a powerful tool used in various fields like computer graphics, engineering, and data analysis. So, let's dive in and decode this fascinating topic together. Before we talk about matrix operations, it's crucial to understand what a matrix is. A matrix is essentially a rectangular array of numbers arranged in rows and columns. Think of it as a spreadsheet or a grid where each number has its own place, known as an element. For instance, a matrix can look like this. 1, 2, 3, 4. This is a 2 by 2 matrix because it has 2 rows and 2 columns. Matrices can be of any size, and each has its own set of rules for operations. There are several operations we can perform with matrices, each serving a unique purpose. Today, we'll focus on the most fundamental ones: addition and subtraction. Adding or subtracting matrices is like playing a matching game. You just add or subtract the corresponding elements. But remember, you can only add or subtract matrices if they have the same size. Here's a simple example. Matrix A matrix B A plus B. 1 2 plus 4 5 equals 5 7. 3 4 6 7 9 11. Multiplication. Matrix multiplication is a bit trickier. You multiply rows by columns. The number of columns in the first matrix should match the number of rows in the second. It might sound complex, but once you get the hang of it, it's a game changer. Scalar operations. Scalar operations involve a single number, known as a scalar, and a matrix. You simply multiply or divide each element of the matrix by the scalar. It's like resizing the entire matrix by that number. Matrix operations are not just theoretical. They have real-world applications. They're used in computer graphics to transform shapes, in engineering for simulations, and in economics for modeling financial systems. Understanding how to manipulate matrices can open doors to advanced topics like machine learning and robotics. Thank you for joining me on this mathematical adventure. Matrix operations might seem daunting at first, but with practice, you'll find them an invaluable tool in your mathematical toolkit. Remember, it's not just about the numbers. It's about understanding the patterns and principles behind them. Keep exploring, and happy learning!